Okay, today we're looking at how to answer exam questions again, and we're going to have another look at a 6-mark question. And this case we're also going to focus on uncertainty, and what we mean by the term uncertainty. So this is an example of a 6-mark question asking for you to determine the density of an irregular shaped object, which you have done in previous lessons. But as we're thinking about this, we're going to be boxing the command word, which is planning an experiment. We're also going to be underlining key words. So here we have a student wants to determine the density, and it's an irregular shaped object. Okay, and if we're going to plan this, we need to think about what we need to include in this question. So the first thing that should come to mind is that you are going to need to talk about the idea of what we mean by density, and you should be able to remember the equation for density, which is equal to mass divided by volume. So obviously if we're going to talk about how we're going to measure the density of something, you're going to need to talk about that equation. Then it asks you, it's an irregular shaped object, and you need to think about how you are going to measure the mass, but you can remember that there's going to be some sort of balance, wasn't it? There's an electronic balance to measure the mass. You might want to talk about the idea that that's measured in grams. Okay. And then in order to complete the calculation, you need to work out what the volume is. Now, because it's an irregular shaped object, you need to think back to how you measured the volume of an irregular shaped object, and it was by displacement of water, if you remember. So you then need to describe one way of doing this. So it might be the case that you want to use a measuring cylinder. Okay. And you might want to have the initial volume, of water at the beginning, and then you put the irregular object in, don't you? And you work out what the final volume is. Okay. And I'm going to actually write final volume up here, because once you measure the final volume, if you then take away the initial volume, that will get you the change in volume, and that will give you the volume of the actual object. Okay, so it's the change that you want, change in volume, which will tell you how much the irregular object, the volume of it, and the unit for that is normally in centimeters cubed. Okay, so once you have got your plan, your very basic plan, you would then need to describe it in your own words, in sentences, to describe how you would do that, and that would be your 6-mark answer. So let's just have a little look. This is a typical answer. This would be the mark scheme for this, or somebody's answer for this. The idea that you had to weigh the object first using a balance, which we talked about. You also had to use a measuring cylinder with water, and you record the initial volume. Then you put the object into the measuring cylinder, making sure it's completely submerged. That's quite important. You don't want any bits sticking out. Then you record the new volume, okay, and then you are going to take away the initial volume from the new volume, and that will give you the volume of the object. And then finally you're going to calculate density by dividing the mass by the volume. So there's your answers. Okay, so here's the official mark scheme for that question, and you'll notice that it's in 3 levels, and for level 3 we need to have the method leading to a valid outcome with all key steps identified and logically sequenced. In other words, it all needs to make sense. You need to describe exactly what you're going to do. And you will notice that when we were planning our answer, we mentioned this bit. We said how to measure the mass using a balance. We then gave instructions as to how to measure the volume by placing it in a measuring cylinder and using this equation. So the final volume of the water minus the initial volume will give us the volume of the irregular object. And then finally we were going to write down the equation density equals mass divided by volume in order to calculate the density. So our plan would have covered all of those key points in order to get us 6 marks. Now you'll notice that there is an alternative method here that you could use. You don't have to write about both methods. You could write about one or other method, it doesn't really matter. This was the method where you had to use a displacement or eureka can and collect the water to measure the volume of the water that had been displaced. So that was the other method that we looked at. Okay, so for task 1, I would like you to describe a method for measuring the density of a liquid this time. So this is the work that you did on Wednesday, and I would like you to go through exactly the same procedure as I did with the exemplar just now. And I'd like you to write me out a detailed method as to how you would measure the density of a liquid. The next thing that we're going to look at is this idea of determining uncertainty in readings, as this comes up a lot in exam questions. And there's an example here, an exam question, which asks you to determine the uncertainty of these results. And in order to do that, you need to work out the range of the data and divide that range by 2, and that will give you the uncertainty around the mean. In other words, it will tell you how much the values will vary around the mean. So I'm just going to do a worked example here. So first of all, we're going to calculate the range, which will be 1120, which is the biggest value, minus the smallest value, which was 960, and that gives us a range of 160. So in order to calculate the uncertainty, which is what we've been asked to do, we would then divide the value for the range, which is 160, you divide it by 2, and that will give us an answer of 80. So in the answer box, you would say that the uncertainty of that data around the mean is plus or minus 80 kilograms per meter cubed. So here is your task 2. I would like you to determine the uncertainty of these results. So in this situation, you need to do the calculations for aluminium using this data, 1, 2, 3. Okay, and you need another reading for uncertainty for lead using that data there. So remember, you had to calculate the range of the data for each metal and divide it by 2 to give you the uncertainty. I'd like you to calculate that and write that up in your exercise books and submit it on Show My Homework. So the third task is looking at the uncertainty when you use certain measuring instruments. In this case, we've got 2 examples. One is a ruler. So a ruler can measure to 1 millimetre. So the uncertainty is going to be half of that, which is plus or minus 0.5 millimetres. On digital instruments, you look at the scale on the display, and it will be half of the last value. So if a balance reads 0.01 grams, it means that its uncertainty would be plus or minus half of that. So it would be plus or minus half, 0.05. I'd like you to have a go at calculating the uncertainties for the mass balance and for the vernier calipers, which are on the next 2 slides. And upload your answers to show my homework. Thank you.